In Module 13, we'll be looking at the comparison test. Let's begin. So we have two concepts that we want to be mindful of when looking at the comparison test. The first is if we have two sequences, A and B, and if each respective term in these sequences satisfies the property that AK is less than BK, and if it's also true that the summation of BK converges. And since BK is the larger sequence and it's converging, then we know that the summation of AK would also converge. So if we suppose that a sequence converges, we need to find a sequence a tad bit larger than it that also converges. The second property, looking at those same two series, if the respective terms of B and A are such that BK is less than AK, and notice this time BK is the smaller series, and the summation of BK diverges, then the summation of AK, the larger sequence, would also diverge. Let's look at an example. So for the series from K equals 1 to infinity of the quotient K to the third power over the quantity 2K to the fourth power minus 1, we want to determine if this converges. And if we think that it diverges, we want to find a sequence that is a tad bit smaller than this that diverges, and thus our larger sequence would also diverge. So thinking about this and maybe working backwards, notice that if we take this new quotient K to the third power over the quantity 2K to the fourth power, notice that it is less than our given quotient K to the third power over the quantity 2K to the fourth power minus 1. That is, if you take away the minus 1 in the denominator, it will make it larger. And if you make the denominator larger without altering the numerator, you are going to have a smaller quotient, a smaller number. Taking a look at what we just obtained and canceling out the k's, 3k's in the numerator and 3k's in the denominator, we notice that the quotient 1 over 2k is less than or equal to what we just obtained, k to the third power over the quantity 2k to the fourth power, which again is smaller than our given quotient. We know something about 1 over 2 to the k. It's a p-series. So since the summation from k equals 1 to infinity, notice we have the same limits of this new quotient 1 over 2k, which is a p-series with p equals 1, thus it diverges. And then from the comparison test, we know that our given sequence also diverges. We'll look for any questions that you might have on the discussion board.